The question is whether or not do you think that that's a statistically significant difference. But I think for right now, we're going to go and take a look at some other visualizations.
Okay.
So what did, sorry, so just because I was playing catch up here, what did we do with the training of the CSV? We put that in rows? Or?
We dropped it onto color under marks there.
So there's 3 different auctions we've been buying cars at. Mannheim predominantly.
A lot of this stuff was in the assignment sheet of walking you through how to make some of these visualizations. So if you're not, that's a resource as well. Valerie, there seems to have been some confusion about how much of the assignments they were intended to do, so we probably want to clarify that. So let's open up a new sheet as well, and let's take a look at this vehicle odometer reading. This one was we had a concrete hypothesis that as we increase vehicle odometer reading, or the odometer went up, we would expect to see bad buy going up.
Column?
So let's start with the columns, yep. And then bad buy to rows. So this is not a very informative plot. Does anybody have any idea for why we ended up with a plot that doesn't seem to make any sense?
We're summing everything.
We're summing everything, okay. So what we've got here is we've only got one point on here. And if you look at this, that point corresponds to roughly 5.2 million or 5.2 billion miles. And 9,000, 9,000 is bad buys.
All is summing all
bad buys.
All the miles with all the bad cars.
So all the miles with all the bad cars, right? So we could fix this by taking averages, but that probably wouldn't get us any closer. Because what we've done is we've taken all of our data and plotted it on one point. We don't really want to see everything summarized into one point. One thing you could do is you could go and make this a dimension. So instead of doing that, you dimension right above, clicking that, and we get something that's a little more informative. So the sum that we had condensed everything to kind of one value. This dimension says treat every row as its own separate point. So now every a point here corresponds to a particular reading of a vehicle odometer. And then the height of it is equal to the sum of the bad buys for that vehicle odometer. And we could take the average of these bad buys instead of sum, because it turns out sum is the default for when you drag something, and it's never right. You never ever want to take the sum of something. It is the worst default I've seen in software in a long time. So let's take the average of that instead. It still isn't very informative. It's hard to look at this and say anything about whether or not there's a relationship between bad buy, a vehicle odometer and bad buys. So, does anybody have any other suggestions on what we want to do with something like this? Rosalind?
You can use bins.
What is bins about?
I think it splits a categorical variable into the different discrete values.
Yeah.
0 and 1. Up or down.
We could bin it. So what we really want is something like a histogram, right?
Yeah.
We want a histogram for each kind of range of odometer readings. What's the average bad buy? So we can get something like that by going over to our vehicle odometer on the side to the left here, doing a drop down, and going up to create, and then clicking bins. And then just that suggests the default size of bins. You could change it if you wanted to, but we could leave that as the default size and clicking OK. That means it breaks it up into bin sizes of 1,500 miles. And then now we can get rid of the columns up there. Just remove that and drag out vehicle odometer bin. And if you could right click or now click on that show me up on the top right of Tableau there, it will get rid of that. There we go. And now this is a little more informative. Our hypothesis was that as vehicle odometer reading goes up, the probability of being a bad buy goes up. Is that what this plot shows?
After a certain point,
Sort of.
Yes and no.
Okay. Well, you said sort of.
no, that was Ryan.
Oh, right. I'm sorry. These masks make it hard for me to tell who said what. Ryan, you said sort of.
Yeah. It looks like around like 25K after that point then it sort of generally trends up, but below 25K miles, that's, yeah.
Who's got a story for this?
So at very low mileage, there's a small percentage of cars that, have a defect, and you're gonna see that at a low mileage. The cars that have been driven for a while, some of those defects have already been worked out. And then at the very, very end, there's probably a very low percentage of cars that have that mileage anyways that have been sold, so that might make some of those statistics look greater.
Okay.
Just a thought.
So you're saying that this is something like that's often referred to as a bathtub curve, if you've ever heard that term, where like it turns out that things fail either at the end of their useful lifespan or they fail right away. If you might not be surprised to hear this, and I'm a giant nerd, and I happen to run my own servers at home with a decent number of hard drives. And with hard drives, it turns out that it's very common for hard drives to fail shortly after you put them into use. And so before you ever store valuable data on them, you kind of burn them in. Stress test them a little bit to make sure there's not manufacturing defects that make them fail. But then all hard drives will fail eventually, and so if you're not backing up your data, back up your data. But all hard drives will fail eventually, and maybe that's what we're seeing down here. Common bathtub curve in almost anything. Any kind of manufacturing, anytime you manufacture something complicated. But Caroline, you mentioned something about you thought at the end it might not be much in the way of like statistical significance. What do you think is happening there?
So there may, I don't know, but there may be one car that was sold for 113 kilometers on the odometer reading, and that only average was, that kind of made the average, or maybe two cars together, two have an average, but that may kind of skew your results a little bit.
Okay. How could we test this? Mark?
You can get a much different picture if you do it by count.
By count. So you mean like?
Is that by, instead of averaging it, just doing it by count, the actual number of cars.
Okay. Well, let's take a look at that. Can you go to that and drop down and then go to measure and count?
How do I zoom out?
So what is this telling us?
So, it's basically saying kind of what you'd expect, I guess. Those cars that you buy and are bad buys are in the higher range mileage, 70, 80,000 and so on. But then once you get into the really high mileage, I guess there's just not that much cars being sold.
But is that what count is doing? We're all still figuring out kind of what these functions are doing. What is count doing here? Dennis?
I think count's just showing you the average life of vehicles that are being sold at auction. So your mean is somewhere around 77,000.
Okay, so Andrew?
Count is showing the number of values that have a bad buy value. So you're getting the combination of zeros and ones.